What is an API? API, or Application Programming Interface, is a convenient and standard way to expose a set of functions related to a specific dataset and services. APIs also lend to reusability of code. An API publishes a set of functions or methods that can be used programmatically to invoke operations, access data, and store data. Access to an API can be controlled by specific access method, for example, public keys, if so warranted by the application. On completion of this lesson, you will be able to list the Ethereum APIs that facilitate Dapp development, explain the functions and usage details of the various APIs. Two well-known examples of APIs outside Ethereum blockchain are the Twitter API to access tweets that can be filtered by query terms, Google Map APIs that allow for applications to embed the map features such as geolocation in their own applications, leveraging and reusing the power of Google Map API. Why are APIs important? Blockchain server and node provide the blockchain functionality and data structures. How do applications call the functions of a blockchain? Invoke them. How do they use them for accomplishing tasks of an application? We need a well-defined standard approach to get things done for a Dapp. The answer is in the APIs. In our case, the specific APIs expose the services of the blockchain server using standard functions. When you develop a Dapp, interactions with the get node and the blockchain server is accomplished by invoking these APIs. For example, in the command miner.start, miner is the API and start is the function of the miner API. Why in the context of a Dapp are we learning about APIs? Blockchain technology has ushered in a whole new culture in software and systems development and management. In the beginning, software systems were proprietary products. Eventually, some moved on to become open source. With blockchain technology, developers are not only contributors to software, many of them help run the network by standing up nodes, supporting mining, etc. More importantly, developers also propose and vote on improvements and changes to the blockchain protocol. Thus, we want you to be more than developers. You can be contributors. You can be committers to code. You can help with the governance and help shape the protocol. This is the technology culture underlying the blockchain revolution. To enable you to be informed developers in this context, you need a basic knowledge of the APIs and the inner workings. Ethereum APIs. So what are the APIs Ethereum provides? There are two major categories of APIs. The first one is the management APIs that includes admin, debug, miner, personal, and text pool. They support methods for management of the get node. The second one is the Web3 API. Web3, ETH, and Net. They support methods for development of Dapps. Next, we'll examine each of the APIs in detail. Admin. The admin API allows you to use functions to work with your get instance, including network peer and the RPC endpoint management. Examples: admin.addPeer, admin.nodeinfo. In this case, admin is the API, and addPeer and nodeinfo are functions of the admin API. You can observe that admin supports functions for management of the node. Debug API. Example: debug.dumpBlock16. This will display the block header details of block 16. You can observe that the debug API provides you the ability to peek into the blockchain, study it, and debug any issues by looking at the block. Miner API. The Miner API allows you to control the node's mining operation and set various mining specific settings. Very easy to understand. Example, miner.start, miner.stop are sample functions that will start and stop the miner. You can also say miner.start 6, where 6 parallel threads are assigned to the mining operation. Personal API deals with the creation and management of accounts within a node. It also manages private keys in the key store. That's why it is called Personal API. Example, personal.newAccount will create a new account within a node. TX Pool API. The TX Pool or Transaction Pool API gives you access to several non-standard RPC methods to inspect the contents of the transaction pool containing all the currently pending transactions, as well as those queued for future processing. Example, txpool.inspect lists you all the pending transactions for you to peruse and collect for building a block of transactions. So far, we looked at the management APIs of Ethereum. Now on to the Web3 APIs. Web3.js library, when included in the Dapp, lets you use Web3 object provided by the Web3.js library and all its objects. It also lets you communicate with a local node through the RPC port. It also provides access to the ETH object and its function via web3.eth and net object via web3.net and their respective function. You can also access other management APIs to the Web3 object. There is also a Whisper API, web3.ssh. It is used for secure gossiping and enables the Whisper protocol. Web3 is a JavaScript library that's specifically designed for use with web client of Ethereum Dapps. It's a portal through which all the underlying operations of the Ethereum node and the blockchain server can be invoked. For example, a smart contract deployment and smart contract function invocation. You will use Web3 in the development of a front end of the Dapp and for interacting with the blockchain. Now that we know the APIs, here is a simple architecture of a Dapp. It comprises multiple full nodes with only 3 of them, node 1, 2, and n. You can also see all the APIs discussed. Get command is used to expose the RPC port as well as the APIs. So far, we discussed the architecture and API details. When a web request is initiated by a user, and if it's a regular web app request, it is directed to the HTTP endpoint, say port 8080, and to the web server to be executed. For a Dapp, the GET client has to expose an RPC endpoint using RPC port command. A Web3 object is instantiated in the web page script. Recall that Web3.js is a JavaScript library. Requests or calls are invoked on the Web3 object. Requests are transmitted as a JSON over RPC pipeline between the web client and the GET client. Requested call and function is executed using appropriate API and smart contract code, and the result returned to the web client. As a recap, in this module, we introduce a way of looking at the blockchain technology, blockchain server, and client. We created a 2-node peer-to-peer blockchain network with ID 15. We learned the foundational knowledge required to be a developer of a Dapp and a blockchain citizen. We explored the Dapp architecture and the supporting APIs. Armed with all this knowledge, we are ready to develop our first Dapp.